Let's look at this one here next. So we're working on the product of these two rational expressions. And the first thing we need to do is factor each of the numerators and each of the denominators as far as possible. Then we'll multiply them together and go from there. Is that where it's in it? Yep. Nope. Two or three or four. Okay. All right. It should go down there. Go to the right spot this time. All right. Now, as we look at the four main spots, the one that kind of catches my attention is the 5x. Because it is a single term, a single expression. There's nothing we can do to it. There's no greatest common factor. There's no ways to factor it because it is a monomial, a single term. Next place I would look is at this 5x and 5x squared. We do have two terms, and there's a greatest common factor of what? Well, 5's in common with both, yes? So 5 would be part of the greatest common factor. We would also have x, yes? Now, one thing I want to bring attention to is the fact that the 5x squared, our variable with the biggest exponent, is what? It's going to be negative, yes? As we saw in the last one, that kind of didn't cause issues, but we had to factor that negative out to get it to be positive later on, yes? And really, if the variable with the biggest exponent when we're factoring is negative, no matter where it's placed it's at, it might be nice to factor that negative out to make it positive. Because if we factor a negative 5x out of negative 5x squared, it would go from negative to positive. 5 factors out completely, and it's going to turn the x squared into x, which is fine. Now the first 5x, if we factor 5x out of it, we factor everything out, we would get 1. But because we're factoring a negative out of a positive, it's going to become negative. Now we will switch it so that we have x minus 1, we have it written in standard form, but we can leave it as this here. Questions on what we've done so far? Do we want to do the numerator, the top one, or the bottom one next? Top one. X squared minus 5x plus 6. Now there is no greatest common factor between x squared, 5x, and 6, so we'd have our two sets of parentheses with 3 spaces. Since the third term is positive, the signs are the same and match the sign of the middle term. So we have negative and negative. Now our factors of x squared are what? X and x. Now the factors of 6 are 1 and 6 or 2 and 3. Which one do we want to try first? 2 and 3. Now we can check this here off to the side, make sure we have the correct factors. X times negative 3 would be negative 3x. Negative 2 times x would be negative 2x. You're welcome. And negative 2x minus 3x or negative 3x minus 2x would indeed give us the negative 5x that we wanted. So it tells us that these are indeed the correct factors. Now that brings us down to our last term to factor, x squared minus 4x plus 3. There is no greatest common factor between these three terms. And since the third term is positive, our signs are the same and match the sign of the middle term. So we'd have minus and minus. Factors of x squared are x and x. We only have one set. Factors of 3. And actually, this is the only setup that we could possibly have. We can check and make sure. X times negative 3 would be negative 3x. Negative 1 times x is negative x. And negative 3 minus 1, negative 3x minus x would indeed be negative 4x. So those are the correct middle terms. Correct middle terms, so those are the correct factors. Questions on how we got to this point here? Now at this point here, we can multiply these together, so we would have negative 5x. Now our negative x plus 1, we can rewrite it as x minus 1. Then we're going to multiply it by our x minus 2 and x minus 3. On bottom, we're going to move that 5x to the front. And it's being multiplied by our x minus 1 and x minus 3. We kind of just moved it all together. Questions on this here? So what's in common on top and bottom? What can we simplify? We can simplify the x minus 1 with the x minus 1. What else? X minus 3 and x minus 3. Anything else? So we have 5x and 5x. They would simplify. Even though it's negative 5x and 5x, because it's really, we can say that this negative 5x is what? Negative 1 times 5x, because that's just multiplication. So the 5x on top would still match up with our 5x on bottom. But that means on top of the fraction, we would still have the x minus 2 and the negative 1. So it would be negative 1 times x minus 2. We have 1 on bottom, so that would be it. Now at this point here, if we wanted to find the restrictions, we would set 5x, x minus 1 and x minus 3 equal to 0, and see that x cannot be 0, 1, or 3. Questions on how we multiply these here? All right. Two x squared minus 10x over x squared minus 25 times x plus 3 over 2x squared. Now again, when we start these multiplications, we want to factor everything as far as possible and then simplify from there. For me, when I'm looking at this and starting factoring, I actually look at the second fraction. Because on bottom we have 2x squared, that is one term. We can't simplify it any further because there is only a single term. It's just going to be 2x squared. Nothing we can do with it. On top, we have x plus 3. Because of the plus, we do have two terms. We have x and 3. But is there a greatest common factor between x and 3? No. The degree is 1. So really, that second expression is simplified. Now, we can put parentheses around the x plus 3 because we're going to need them later, but just to signify that those two terms are stuck together. Now we can look at our first rational expression, 2x squared minus 10x and x squared minus 25. If we look at the top, is there a greatest common factor between 2x squared and 10x? And it would be 2x. And if I factor 2x out of 2x squared, we get x. Minus, I factor 2 out of 10. 10 divided by 2 is 5. And the x factor is out completely, yes? How would I know not to factor out, say, negative 2x? Because it would be negative x plus 5. Since the x squared, our variable with the biggest exponent, is already positive, there's no reason to factor a negative out. Now in the last two, our variable with the biggest exponent was negative, so we want to pull that negative out so that we get this positive x term, or positive x squared, that variable with the biggest exponent.
Please come to the office. Ridge Phillips, please come to the office.
Will still be positive. Now the last thing we need to factor is x squared minus 25. There is no greatest common factor. And we only have two terms. Well, what times itself is x squared? X and x. What times itself is 25? 5. So this would be x plus 5 and x minus 5 because it is a difference of perfect squares. Questions on this here? Next thing we need to do is multiply them together. So on top we would have 2x times x minus 5 times x plus 3. On bottom, we're going to move that 2x squared out front just to keep track of it. But it is also being multiplied by x plus 5 times x minus 5. What's in common on top and bottom? X minus 5, x minus 5. Anything else? So the 2x, so it'd be tempting to go 2x and they simplify out completely, yes? But that's not quite the case because the 2 over 2 would simplify out completely because there's 1, 2 on top, 1, 2 on bottom. But with our x's, how many x's do we have on top? How many do we have on bottom? So one of the ones on top will simplify with one of the ones on bottom. But unfortunately, they're not going to cancel out completely because this one will cancel out with one of these, but I will still have a singular x on bottom. On top, we still have the x plus 3, and on bottom, we still have the expression x plus 5, telling us that this is going to simplify to x plus 3 over x times x plus 5. Questions on this here? We kind of understand how we got there? We ready for another one? C cubed plus 8 over c to the 5th minus 4c to the 3rd times c to the 6th minus 4c to the 5th plus 4c to the 4th over c squared minus 2c plus 4. Now this does seem like a very harder problem. There's a lot more to it. And really, again, with any of these here, take it step by step, part by part, and we go from there. Now the bottom of our first expression, c to the 5th minus 4c to the 3rd, has a greatest common factor of what? C to the 3rd. Because I can take 3 c's away from c to the 5th. If I take 3 away, I'm left with c squared minus. Well, if I take 3 c's away from c cubed, we're just left with the 4. Also notice on the numerator of the second rational expression, it has a greatest common factor of c to the 4th, yes? Which is going to leave us with c squared minus 4c plus 4. Now we have 2 places left. We have the c squared minus 2c plus 4, and we have c cubed plus 8. I'm going to leave the c squared minus 2c plus 4 alone for a moment. Because I know that c cubed plus 8 is a sum of 2 cubes. C to the 3rd kind of gives it away. Because what times itself 3 times is c cubed? Well, that's just c. So that's fine. So that tells us that we have that. What times itself 3 times is 8? 2. So 2 to the 3rd So really we can replace a and b in the cubic form with c and 2. So that tells us that we would have c plus 2 in the first. Now, our a squared, we would have c squared minus ab, so that'd be c times 2, plus b squared, which would be 2 squared, yes? Wait a minute. C plus 2. If I simplified this quadratic part of it, c squared would be c squared minus c times 2 is 2c plus 2 squared would be 4, yes? That looks familiar, doesn't it? Those are already the same. Now, if this factors, if c squared minus 2c plus 4 factors, that's good, but it's already in common on top and bottom. So whatever that factored to, if it does factor, would match the same factors as c squared minus 2c plus 4, yes? But if you remember back, I told y'all, we went over the fact that the quadratic part of a sum or difference of perfect cubes will never factor. So that tells me that since I simplified it down, c squared minus 2c plus 4 won't factor because it's the quadratic part of a sum of two cubes. But that also means this other expression down here doesn't factor either. Even if it did, since I have it matching on top and bottom, it doesn't matter if it factors or not because they'll simplify either way. Does that make sense? Because they're already matching, why go further than that? Now, the other two expressions here will factor. Do we want to factor c squared minus 4 first or c squared minus 4c plus 4? C squared minus 4. Now it will factor to what? C plus 2 and c minus 2. It's a difference of perfect squares. C times c gives us c squared. 2 times 2 gives us 4, so we get plus and minus. Now our c squared minus 4c plus 4, since the third term is positive, the signs are the same and match the sign of the middle term. So minus and minus. Factors of c squared are c and c. Factors of 4 are 1 and 4, 2 and 2. Well, if anything's going to match up, we're going to need it to be what? 2 and 2. And those would indeed be the correct factors. Okay. Now at this point here, we multiply them together, yes? And we rewrite it and they're all on the same line? Or? And that's essentially the same thing. Now we do have to be careful because we have c to the fourth and c third. We don't just kind of lose track of them. But at this point here, I can say c plus 2 and c plus 2 cancel, yes? We can also say a c minus 2 is going to cancel with a c minus 2. And our c squared minus 2c plus 4 cancels with c squared minus 2c plus 4. Now, I do this here because I know 3 of the c's down here will cancel with 3 of the ones up here, yes? So it's really changing it from the fourth power to the first. Even if it wasn't just 1, if we had c squared on bottom, c to the fifth on top, well, we know the 2 on bottom will cancel with 2 to the 5 on top, changing it from c to the fifth to c to the third. Telling us what? On top, c times c minus 2. Is there anything left on bottom? Giving us that there. So what do we think of this problem here? Is it a lot harder than the first few we did? It's time-consuming more step, yes? This did not come out of the algebra book. This I got off a college website. for college algebra. So like I've said already a few times, college algebra and what we do in here isn't that big of a difference. It's just one further step. We just had to factor out a bunch of greatest common factors, do our normal factoring steps, and we got there. Questions on this here? I will jump through this. I wouldn't write it down because we know the steps. Because I'm going to skip steps a good bit. X cubed minus 27, we'd have x in 3. Telling us it's x minus 3 times x squared plus 3x plus 9. Oh, those are already the same. No reason to do that. Here, greatest common factor of x squared. On top, we would have these here are already as simplified as they get. Our x squared minus 9 would be x plus 3 and x minus 3. Make sure I didn't just drop a sign. Nope, we're good. And that should be cubed. Yep. So not everything on the top and bottom simplified out completely. We still have the x minus 3 and x minus 3. Because, x minus 3 and x minus 3, there is no plus. That's as far as it goes. Now at this point here, there's no reason to multiply x minus 3 squared x minus 3 by x minus 3 to get back to x squared minus 6x plus 9. It's the same thing. Questions? I don't think we have to do too many of these because we do have two fractions being multiplied together. What's the denominator of this second part? 1. X plus 2 is as simplified as it gets. Now, x squared plus 3x plus 9. There's a chance that it could factor, but I almost had a little bit of a warning light about factoring it because of the cubic. Because I know I'm going to get a cubic, out of that cubic, I'm going to get a quadratic. I would also notice the fact that the a and b, a is going to be x, b is going to be 3, yes? So there's a good chance I'm going to get 3 and 9 out of this, yes? So we have that. Now for the first part, a minus b would become what? X minus 3, yes? A squared, well, that's going to be x squared, which is just x squared, yes? Plus a times b would be 3x, plus b squared would be plus 9, yes? Those would simplify because they're in common, leaving me with x plus 2 on top and x minus 3 on bottom. Questions on this here? So if we did the restrictions by the book, how the book would say, we list the ones that got removed, yes? The only one that got removed from the bottom of the fraction was what? The x squared plus 3x plus 9, yes? We said it's not factorable. So the only possible solutions we could have are irrational. Because if they're complex, they're not real numbers. And since they're not real numbers, there is no real value of x that would make that part be 0, yes? And actually, it works out that they aren't real numbers. Because, apparently I shut that down, because it would be square root of 3 squared, 9 minus 4 times 1 times 9. That's not a real number, which means the one part that we canceled out can't be 0, which means it has no restrictions because it can't cause a division of 0. The only one that if we were to list it would be x cannot be 3. It's already there. Questions? We feel comfortable with these here? Because this ends up being x minus 7 over x plus 2. That's actually it.